Hello. Welcome to the FME Server Month webinars for all things FME Server. My name is Samuel McDonald, and in this webinar, which is the fourth and final entry in our series, we are going to cover dynamic engines and scaling in FME Server. As I do with each of these webinars, I'm going to quickly introduce myself in a little more detail before we get started. For those who may not have attended the previous webinars, or for those who have simply forgotten who I am. For those who do remember, I promise this is the last time for this series. I am an electronic engineer who works with One Spatial Australia as one of their senior consultants, primarily working on delivering FME-oriented solutions to various clients and groups. If anyone watching this webinar is interested in the FME product line or delivering solutions in FME, please feel free to contact me via the email you see on the screen. Alternatively, feel free to reach out to me on LinkedIn. With that out of the way, let's quickly review what is covered in this series with our trusty roadmap. The FME Server Month webinars consist of 4 webinars in total, covering a list of topics chosen by the technical team here at One Spatial. The topics that we have already covered are an introduction to FME Server, an overall guide to what FME Server has to offer, self-service, putting the power in your users' hands with easy to set up self-service portals, and enterprise integration, easily integrating FME with new and existing enterprise integration patterns. As you may have guessed, the topic that we're going to be covering today is dynamic engines and scaling, making the most of FME Server's flexibility to cut costs and improve performance. The intention of these webinars is to provide a good insight into FME Server and how it can be easily used to deliver on commonly requested features, such as you see in this roadmap. In each of these webinars, I generally ask the question right after the roadmap, which is, so, what is this thing that I'm talking about? And in the spirit of that, let's surmise now. So, what exactly are dynamic engines? Simply put, they are a deviation from the standard pricing model for FME Server that isn't quite FME Cloud either. Basically, it's a new and potentially cost-effective way of purchasing processing power for FME Server specifically. Unlike the traditional engines, which from this point on I'm going to refer to as standard engines, and their fixed licensing cost, dynamic engines work on a credit system that can be topped up as required. Each of these credits amounts to 1 hour of engine CPU time, and it's important to note the use of the term CPU time here, as it is the only component of each overall job that will actually consume your credits. You may have workflows that spend significant amount of time waiting for data, for example. With dynamic engines, you would only pay for the CPU time itself, not the full run time. This CPU time is made up of user time, which is FME doing the work, and system time, which is the OS doing the work on FME's behalf. Another really cool element to dynamic engines is that you are not really limited with the quantity of engines that you can have. Spin up as many or as few as you want, they will all simply use the same credit pool. I believe SAFE refers to this as engineless, meaning that no aspect of the license has anything to do with the number of engines available, unlike standard engines. So, the showdown, the title fight, the championship. How do standard and dynamic engines compare against each other? Standard engines are the traditional approach and have a license per engine pricing model. Given that you are paying a set amount per engine, regardless of runtime, it stands to reason that these are still very good for high traffic and high availability requirements. It is also important to note that these engines run jobs in the exact same way that dynamic engines do. Speaking of, dynamic engines are the new approach introduced in 2020, so you must be using FME Server 2020 Plus. As I mentioned, they use a credit system where you can purchase CPU compute time for a pool of engines that can be dynamically defined, hence the name. They use the use of credits only when they are doing actual work makes them quite favorable for infrequent processes and processes that may wait and listen for periods of time. It is also important to note that these engines run jobs in the exact same way that standard engines do. Now, the reason I keep pointing out that these process jobs in the same way is to segue inelegantly into the real relationship between these two engine approaches, supporting one another. It still remains that Standard engines are cost effective for high CPU usage requirements. You don't realistically want to be taking on dynamic engines and burning through your credits faster than you really need to be. Depending on your use case, standard engines can still provide a cost effective backbone, if you will, for high traffic queues, your primary engines that are the first choice to route jobs to generally. Where dynamic engines comes into this is offsetting the deficits of the traditional pricing model or offering an alternative to it. As previously mentioned, dynamic engines may just be outright more cost effective depending on the use case. Processes such as data streaming that spend a lot of time waiting don't contribute a lot of CPU time, so why tie up a standard engine if you don't need to? But another really important benefit and strength to dynamic engines is how easy they provide scalability. You can potentially assign dynamic engines to job queues that are seeing too much traffic to alleviate the backlog of jobs, and then remove them from the queue when it has settled. This can be done very quickly vertically by simply adding more dynamic engine instances to your installation, but they also make horizontal scaling a bit easier, given that you don't have to scale your license to provide more distributed engine installations, which is something that we'll be getting into shortly. So, with all that being said, let's look at getting started with dynamic engines. And with all these webinars, the first thing that we need is an FME server installation. And here's one that I prepared earlier on an EC2 instance. Now, quick note that this instance is a full installation with the core, engines, web interface, and queue, but it has been installed in a distributed configuration with the database actually being hosted separately. The reason that I've done this, even though this is a singular installation at the moment, is so that we can dive straight into deploying some distributed engines later. We just need to point them to the same database and the same file share. So, dynamic engines. What do we need to get started? The first thing that we need is a license that supports them. So let's just navigate over to our licensing page, which in 2021 is under System Configuration Licensing. Once we get there, we can see what our license status is. Now, let's quickly talk licenses. The base license that you can get for FME server comes with the first standard engine, and it is this base license that you actually need to purchase credits for dynamic engines. Everything additional after this base license with regard to additional standard engines or dynamic engine credits is at your own discretion. Do with it as you need. The license that I have in place for this demonstration is actually the evaluation license, which lets me quickly go into a good public service announcement for everyone watching this. The free trial license for FME server comes with 60 days with 2 standard engines, and as well as 100 hours of dynamic engines processing time. If you were interested in trying out anything that I've discussed or shown, you should definitely consider checking it out. You might even go as far as using it for a demonstration like a certain someone, because it makes impromptu testing and evaluation just that easy. So, taking a look at the bottom of this licensing page, we can see that our dynamic engines credits is visible, as well as a couple of settings. This will be your easiest go-to location for checking the balance that you have for your dynamic engines. Given that I have barely scratched the allocation of this evaluation license, let's start creating some dynamic engines. Now, to do this, we're going to navigate to Engine Management, Engines in 2021, and we're at the Engine Management page. Now, I'm going to need people to really focus for this part. It's really quite complex. To get started with dynamic engines, what I need to do is, firstly, we can see that I've got my 2 standard engines. We need to navigate to hosts, where we've got our singular host here. And on the right-hand side of that, there's a field for dynamic engines. I want 4 dynamic engines, so I'm going to click the up arrow 4 times. And then I'm going to click the change button. And it's going to ask me if I want the engines. And I'm going to say, yes, I want the engines. And it's going to go off and organize the engines. And there are my engines. I'm sorry if I went a bit too fast for anyone there. I know it's really complex, and honestly, this sarcasm is probably getting a bit old for everyone now. The reality is that spinning up dynamic engines really is simple. It's really straightforward, and all you need to do is go through this GUI. Now, This is how you do it for your Windows installations, Linux, Mac. But if you're running a containerized FME server installation on Kubernetes, you actually can't do it through the GUI. You have to do it through a YAML configuration file, which I believe off the top of my head is your values file. So that's the only variation for that. But for the most part, defining dynamic engines, extremely straightforward. Taking a look at the engines we've just created, we can see that all of the dynamic engines belong to the default queue, same as our standard engines. Newly created engines will default to the default queue as this is the default behavior. I really couldn't resist wording it like that. What this means is that in its simplest form, with no variation to queues, a dynamic engine will begin to assume jobs that are assigned to the default queue, which is a special queue that jobs will default to if they have not been assigned to an alternative queue. This is probably not ideal, given that I have my two standard engines here to run jobs as well. It makes complete sense that I would ensure jobs go to those standard engines first, and that these dynamic engines pick up the excess if required. Now, there is a couple of ways we can go about this, but we need to start with defining a couple of more queues. And to do that in 2021, that is actually also located under this engine management section, the queues right here. And what you're looking to do with queues is a couple of things. Firstly, it's typically to define prioritizations for jobs. Based on the priority that's assigned to the queue, that job may actually sit in the queue for less time than one's prioritized lower. So if you've got things that are high demand, you can start to dictate that here. Secondly, is you are going to look at starting to map engines to repositories and jobs. Basically, you can prevent certain engines from running certain jobs based on what repository that job will belong to, or it's something you can even specify at the time of running the job. So to get this idea off the ground of what I'm about to demonstrate, which is keeping the dynamic engines in reserve until they're needed, I'm going to create a couple of queues. And the first one that I'm going to create, I'm going to call my, my samples queue. Oop, I'll try that again. Sample queue. And basically what this is going to be is it's going to be a queue that's going to run jobs from the sample repository. So FME server comes with sample workbenches and we're going to make use of them. Click OK. And I've got my first queue. The second one that I'm going to create is going to be the one that keeps the dynamic engines in reserve. So this queue will actually not have any repositories or jobs assigned to it. The point is that nothing runs on this one, but it aggregates the dynamic engines away from active queues. So we're going to give the description of reserve engine queue. And even though the priority doesn't really matter, I'm going to give it 10 just because I want it to look like it's very useless. And there we have it. We have two queues now. And the first thing that I need to do is actually assign the samples repository to that sample queue. And we go to job routing rules to do that. And while I'm at it, I should actually quickly mention that the entire engine management section is new to 2021. So this may be a little foreign for FME server users that are watching this. If you do want to assign the queue, you can go ahead and do that through either the repository directly or through the engine management page on 2020. But we're in 2021 and we're having a look at the new queue control options, which involve the job routing rules and the engine assignment rules. So we're doing it this way. Now, to define a new job route, all I need to do is click new, and I'm going to call it my my sample. Let's call it sample route. And the type, we've got two options for type. We've got metric and repository. Metric, you can actually define routes based on the characteristics of your host machine. So, the characteristics of the jobs themselves. So the average CPU time, elapsed time, and peak memory usage. But we're not going to do that. We're going to go with repository, and the repository that I'm interested in is samples, and the queue I want to assign it to is sample. Enabled, done. So now we've got a queue that says any job coming from samples will go to the queue samples. Moving on to engine assignment rules now, and this is where we're actually going to start assigning engines to the queues themselves. And just like previously, we do this by clicking on new. And the first one I'm going to do is I'm going to do the reserve queue. So reserved, let's call this reserved queue. And the type we're after is actually a name. So you've got two options again here. You've got properties, which allow you to basically define comparators, checks that are basically an if or statements to define these rules. And we're going to get into that. But for now, we're just going to click on name because name is a very simple choose the engine names drop down list. And we've got our 4 dynamic engines, which I'm going to add to this queue, and I'm going to add them to the reserve queue, and we just click OK. Now, if we navigate over to our engines page again, you'll see that those engines no longer belong to the default queue. They are now in our reserve queue. So considering they've been removed from the default queue, they should not actually see anything come to them that isn't actually specified on their queue, which is what we want. We don't want to be wasting credits. Going back to the engine assignment rules, the other one we need to do is the samples queue because it's not assigned at the moment. So if I run something on it, it's not going to do anything. And we'll call it the sample queue. Again, name, and I'm actually just going to let the standard engines run samples by default. And I'll click sample there, and I'll click enable. And now the 2 standard engines are on our sample queue. Again, if we go back to engines, we'll see that they're only on sample queue now, which may not actually be ideal considering that I want these to pick up default jobs as well. So if you wanted, you could either add them to the sample queue, but I don't like that. I'd actually just like to add them back to the default queue in their own rule. I like to keep these things separated, but this is entirely up to you. And just add these 2 to the default queue. Even though the default queue picks up unassigned jobs, we can still assign engines to the default queue. So click OK, go back to engines, and now they're on sample and default, which is great. That's what we want. Now, before we actually start looking at how to get these dynamic engines to start picking up some slack, I think we need to prove that these dynamic engines aren't going to pay attention to the jobs unless we tell them to, because yet again, we don't want to be wasting credits. So what I'm going to do is I'm going to build a schedule that runs one of our samples just to make this deployment work a little bit. Name, test, category, test. You have to give schedules categories. I'm going to do it on interval, repeat on interval, and let's actually repeat every 1 second. And we're going to start immediately and does not expire. So I'm going to make it work. I'm going to use one of the samples, and I'm going to use the lost in download sample because I know that if I specify all 4 layers, that this takes about 4 or 5 seconds to run. So we're going to be generating more jobs than these engines should be able to resolve. If you did want to specify the queue manually, just quickly while we're here, you would go to the advanced and you can actually specify which job queue to send these to. So I could actually overwrite this and go to default, but there is a job route in place for this that says that if it's coming from the sample schedule, that it goes to the samples queue. So I don't need to do anything there. And I'm going to click OK, and that's going to start spinning up some jobs. And we'll go and have a look at jobs, and we can see that we've got running jobs. And I'm just going to add the engine to this. And we can see that there's only 2 jobs spinning up, even though there's a whole heap queued. And now I'm just going to quickly stop this schedule because I really don't need to queue that many jobs. So let's just disable it. Go back to our jobs. And again, what we'll see is that we've got 2 jobs running, no more than 2. And on the right-hand side, we can see that these are engine 1 and engine 2, with no dynamic engines listed here. We've still got a whole heap of jobs sitting in our queue. So this means that coming back to our engines, that these 4 dynamic engines that are sitting in our reserve queue have no awareness that these jobs are occurring. So if I don't want them to be involved, I'm not wasting credits on it. But what if we do want to get them involved? Well, what we need to do is start specifying more assignment rules to get this to work. So let's go ahead and create a new assignment rule again. And this time we're actually going to do a property. So I'm going to call this sample queue busy. And we're going to go with the property. And we need two things basically, because we're going to tell it what the condition is to move the engines, what kind of engine we want to move, what the output queue is too. So firstly, one of our rules is that dynamic. That's all I need. Basically, it's what tells it what engine type it's interested in. And the engine type that we're interested in is the dynamic engine. So we'll keep that as is. And we're going to create a new rule, another rule. And the one that I want in here is actually not here at the moment. So the other two options we've got is the physical memory of the engine host and the process account of the engine host. These are ones that you can use to basically do things reactively if you see that this engine host is running too many processes. But I'm not interested in that just right now. I'm actually interested in a different one. So if you need to have other conditions, you can create a property. And I'm interested in a queue property. And we're interested in the number of queue jobs. The idea is if I've got too many jobs being queued in this queue, I want to speed things up to alleviate that. So number of queue jobs, and the queue we're after is sample. Click OK. And then I have that option here, number of queue jobs sample. And I can say, look, if I get more than, let's say 20 jobs in there, 20 jobs queued, I want this to resolve it. And the last thing that we need to do is that we need to actually specify the sample queue as well. Because what that will do is it will take the dynamic engines and it will assign them to the sample queue instead. And we click OK. And with this assignment rule now in place, let's jump back over to schedules and actually get that schedule running again. So we'll go ahead and enable that. And what I'm expecting to happen is that with this enable, we'll see those jobs start rolling in again and at a quicker rate than those two engines can possibly handle. So we'll see the jobs start to get queued up. And once we exceed 20 jobs in that queue, the 4 dynamic engines should actually be assigned to the samples queue as well as their reserve queue. Now, reserve queue doesn't get any job requests on it, so sample queue will have their full attention. So let's jump over to jobs now, and we can see that there's the 2 jobs running because we've got less than 20 queued. That's great. That's what we expect to see. And as this queue increases, because again, these 2 engines that are running now cannot resolve it, we will see. So let's just see, we're almost at over 20, almost over 20. So we've still just got our 2 engines trying to keep up. 2 engines still trying to keep up. This queue's increasing. And bang, we now have 6 engines working on this because that queue has exceeded the 20 jobs. So looking at the right-hand side again, we've got our 2 standard engines down the bottom, and we've got our 4 dynamic engines at the top. So 6 engines are now running to try and resolve the schedules in response to the schedules queue becoming too busy. If we go to the engines management page, we can actually confirm that those dynamic engines now belong to both the reserve queue and the sample queue. So sample queue is now requesting processing power from them in response to this traffic. So what these dynamic engines have allowed us to do is to leverage additional computing power in response to this traffic, which is honestly a great use of the credits that we have. It's a ad hoc approach. It is, if we need the additional processing power, let's leverage it from our dynamic engines. We'll go ahead and stop that schedule because I'm sure that queue is just getting bigger and bigger. And we'll disable it. And basically, let's have a look at what we've got in our queue still. Yeah, we've got a fair few in our queue. So once that's actually been resolved, and it actually shouldn't take too long to do, we can actually check I can't check the count there, I lied. But what we'll actually see is that once that goes below 20, these 6 engines will go back down to 2 engines because it deems that the requirement's not there anymore. So it will actually then allow those engines to be released from this sample repository. I know it's riveting stuff watching jobs just sort of count down, but I must do it to prove my point. We've seen one of the engines go, and we should see the others are dropping off as they finish their final jobs. So basically now we're back down to our 2 standard engines, and if we not user management, if we go to engine management, back to engines, they've now been put back in their reserve queue. So they no longer need to meet this demand. They're no longer being run. They're no longer consuming credits because we've responded to our peak demand. One of the wonderful benefits of dynamic engines. In the spirit of there is generally more than one way to go about a task in FME, another way that we could look at getting these engines to reassign on demand or as required is through an FME workbench using the REST API. Now, since we're talking the REST API, I'm actually just going to go ahead and navigate over to the REST API documentation. It is conveniently located in FME server. And specifically what we're after to get started with is the metrics endpoint. We can go ahead and try out the metrics endpoint. I'll just need to enter my username and password to generate a token to test this with. Once we've got it, what we can see is that the metrics endpoint gives us a whole heap of very, very relevant information about what's queued on each of the queues, what's running on each of the queues, how long each of the queues are taking. So given that we have this endpoint that has all the queued jobs and running jobs information on a queue by queue basis, and given that it's actually in a fairly standard format too, which is the Prometheus data model for metrics, we should be able to actually extract the relevant information from this fairly quickly with a workbench. So let's move over to a workbench and actually start putting this together very, very, very quickly. And what we can do is start with this workbench that will hit this metrics API and parse the queued jobs from it. The workbench can then use a threshold, similar to what we just did with the assignment rules, to decide when to start moving dynamic engines out of their reserved queue. And we could even go as far as specifying a different low threshold to return them to reserve. What I mean by this, for example, is that we assign them to the sample queue like we did previously when they are at 20 jobs queued, for example, and we return them when that gets down to 5 jobs or less. So much closer to a stabilization, where previously we just did it as a on and off threshold of 20. We go ahead and parameterize these thresholds to enable us to change them in FME server as requires, and then use them to decide whether we need to allocate or deallocate engines from queues, which can also be done by the REST API conveniently. And that's done via the job routes options, which is under transformations. Finish this off and publish it to FME server. Back over into FME server now, and I'll tell you what, I really wish I could work that quickly, but unfortunately it's just the magic of an overlaid video. Going over to automations now, let's set up that workbench that has been published, and we'll build a new automation. And if we're wanting a workbench to constantly check what the state of the queues are, let's just set up the easiest approach would be a schedule being initiated. So we can just set up a schedule which is repeat on interval, and let's do it every minute, just as arbitrary value I'm setting it to, and start immediately, click apply, and we have a schedule set that's going to set off every minute. Next thing we can do is go ahead and put that workspace in place. So repository, published it to engine management, and the workspace name is QAdjust. The web connection, I published the web connection that I've been publishing on. The high threshold, 20 jobs, like we had with the engine assignment. Low threshold, 5 jobs, so it's only when it gets below those 5 jobs in that queue that it will actually then start putting the engines back in the reserve queue. We've got a JSON that specifies what queues we want to watch, and I've just got it pointed to default and sample, which are our 2 that aren't reserve. And we can specify the name of our reserve queue, which is reserve. So this is quite a dynamic way of doing it, which seems in the interest of today's topic. Click apply. We can save this, and we'll just save it as dynamic engine adjust, for example. Don't want a tag. Saved. Start the automation. and that will poll the that will actually poll the API to check the status of the queues every minute. Now, the reason that I'm talking about this as another approach, there's a few reasons, and we'll come back to the first reason I said is that there's more than one way to do these things in FME server. We have pros and cons of each of these. Pro of using this is that it's perhaps a little more versatile, a little more. You can do a lot more that you would like to do in this than necessarily do in the assignment rules because you're defining a custom workflow for it. Read in the JSON message, read in the API, and whatever you want to do with the engines is really limited to what you can do through the API. The downside to this is that you have to run a job for it. And if you think about part of the motivation here is that we're trying to limit our credit use and realistically just optimize this, running a job to check this may not be the best way to go about it. Coming over the assignment rules, and that's a web interface level approach. You don't have to actually run a job for it. The web application does it for you and adjusts it, so you never run a job. However, the engine management options, which includes the engine assignment rules and the job routing rules, are new to 2021. So doing it in a workbench is perhaps a bit more version agnostic. You can do it in 2020 and 2021. I'm sure there's more reasons that you could do one or the other, but it sort of still comes back to this original point of in FME, there's more than one way to do things. You are more than welcome to get creative with this. You've got the dynamic engines in place. You decide how you want to go about managing them. I think we've thoroughly covered scaling your instances vertically, adding more dynamic engines as required to a singular instance with a few good options. I'm sure there's more options, but we're on the time constraint here. So let's move over to how we would horizontally scale using dynamic engines, which basically involves installing a new instance, a distributed engine instance, and spinning up some dynamic engines on it. It's not as fancy as it sounds. So let's go over the deployment status under engine management. This option's in older versions too, but it's moved over to engine management in 2021. And we can see our current deployment. We've got our current host, and we can see our engine manager and all the standard engines and dynamic engines. By the time I'm done, we're going to see a couple more boxes attached to this. So let's move over to another EC2 instance and get started. Now, admittedly, I actually just have another sped up video of me doing this as an overlay for it. But in my defense, who actually wants to watch the installer churn away and me just fill in the fields? It's not particularly exciting. So what I'm going to do is talk briefly about this deployment while the video gives the appearance that I work faster than possible. As we've already established, my primary installation is set up as a distributed installation with the database at a separate location. Now, admittedly, the file share, which you would typically have as at a separate location, I've actually installed on the same machine as the primary installation. And yeah, this would be a no-no if you were looking to do a fault-tolerant installation, but I'm not. I'm simply looking to dangle many distributed engine installations off this singular full installation. So there already is a single point of failure anyway if it goes down. Now, as this video ran through, any eagle eyes might catch on to me choosing the local system account to run services under. And this is actually because I'm not running a service account for this installation. I'm simply using a common username and password for each installation. Now, honestly, I don't advise this as it causes some problems during the installation, which you have to correct. And it will cause havoc if you are trying to work with AD authentication. I simply took the fast approach for setting this up for the purposes of demonstration, because I'm not here to demonstrate a fault-tolerant installation. I'm here to get a distributed installation set up so I can do some more dynamic engine stuff. Close that now that it's done and open up services just quickly, because as I mentioned, I'm going about this a little bit of a roundabout way to avoid using a service account. Not that you shouldn't use a service account, just that I'm not using a service account because I didn't want to set one up. So I just need to quickly log on to the correct account here, which will be my administrator account. That is not how you spell administrator. I can spell. And enter the password. And click apply and should be fine. And we can spin this up now. Start. Done. So now that that engine is spinning up, we should actually see this node registered on the database and it'll be picked up by the primary. So let's go over and check that second host, and look at that. I have a second host. That was pretty easy to get it set up. Now, the thing here is that standard engines, we actually aren't going to see any standard engines because I don't have a license to install these. This is defined as part of the engine process monitor log, and we can actually adjust this, which I'll show later. But let's just quickly unassign those because we don't really want them. And we can go ahead and spin up some dynamic engines like we did with our primary. And now what we should see is we should actually see 4 more primary engines come in that have that IP. There we go. So we've got a new host here, and we've got 4 new dynamic engines. These have been assigned to the default queue. We can go ahead and just look at our engine assignments, and we could actually go ahead and add these to the reserve queue. We could even actually go ahead and update this and say that if it's a dynamic engine, add it to the reserve queue and click OK there. And go back to the engines. And now everything's in the reserve queue, which is really cool. What this means with this different approach of actually assigning it based on the engine type is that any new dynamic engines that we add will now just be by default added to the reserve queue instead of the default queue. So as you add these new engines, you won't be consuming credits with default orientated jobs. So this is probably the better way to do it. Just to prove that this works as it did before, let's go back to the schedule and actually start this schedule again. So the schedule that's going to start flooding that that samples queue. And actually what I'm even going to do is I'm going to make it really work for a little bit, and I'm going to duplicate it. So I can very easily just duplicate this schedule, create a second one that's got all the same parameters, and click OK. And they're both going to be hammering the samples queue now. So what we should see is some jobs start getting queued here very quickly. And when we get above 20 here, which will happen very, very quickly as well, we'll go from 2 engines to 10 engines, if my count is correct. So now we've got 5 engines, and that is 10 engines right there. So we've got this now trying to alleviate the queue over 2 machines, which is really cool. It means that we've added an entire another instance to try and offset our primary instance and take away from the sheer amount of traffic that's coming to it. The last thing that I'm going to talk about before I wrap up is some ideas around speeding up the process of spinning up these distributed engine instances. There's a few things that you can do to sort of expedite the process, and one of which I've been playing around with and I'm fond of is an approach that completely avoids having to go through the installer again, which is using instance images. So for Amazon, for example, that's an AMI, which is basically just a snapshot of a instance that you could then use to build a new instance with. So it'll always come pre-installed with the distributed engine installation. But there's a caveat. You do need to actually make some slight modifications to the config files, which definitely makes some people cringe, myself included at times, because it can go awry. So this is a, use with caution, but food for thought on what you can actually accomplish. So let's get into it and get to the distributed engine instance that we were working with. And we want to navigate to the config files. So I'll quickly show the location. It is under program files. This is obviously for Windows specifically. FME server. Once you're in this FME server root folder, these subpath from here is the same for all installations. You want to be in server. And there's 2 files that we're interested in here. We're interested in FME common config is one of them. And the other one we're interested in is process monitor config engines. Oops. Let's open both of those. And what we're after is the instances where the IP is actually referenced. And we can see them here in the common config. It's the information that's used to register the node. So when I start up the new instance or load from the template, I don't really want an IP that doesn't reflect what the template is. So what I'm actually going to do is I'm actually going to put in something else. I'm going to put in something that's fairly easily searched and replaced. If you were going to run, let's say, a PowerShell or batch script on startup of your new instance, you could actually just go through these files and replace these instances with the new IP that you've got from your new instance. So let's do that. IP address, IP address, IP address. And in process monitor config engines, there's a couple of things we need to do. Firstly, these arguments here are what spun up the standard engines when we actually install this distributed engine. And this doesn't really pay attention to the license. It just tries to spin them up either way. We know for ours that we were using all our standard engines, so we know we're not going to need these. So we can comment them out. And actually, I'm just going to put the overwrite this as well, just for consistency. And the other thing is just on this template start engine line, at the very end, there's an argument that is the engine host name. We don't want that to be an incorrect IP. We want this to be the correct IP, because this, if we go back to the primary, I will quickly show that if we go to our primary, this is how it aggregates engines here. We've got the 128 and the 153 here. So we'll have a new section of engines once we are done here. So, done with those. And we would save both of those. And the last thing we would do is we would actually probably just stop this. The idea is that you want to update the config files and then restart the service. Probably I'll do it with the script. Now, I've already done this and created a new instance of this, which I'm going to navigate to now and just quickly show the updates on this. So if I just open Notepad, because I actually created the template with those files open, so Notepad would just open them for me, which is very convenient. And we'll see these IP addresses here. And all I need to do is just quickly actually grab my new IP and do a quick search and replace on these. Yep, that. Replace all. And I can do it for the other one too. Replace all. So I've replaced all those instances with my new IP address. I can save that. I can save that. And I can go to my services and I can now start this. And actually, you'd probably get the script to change this back to automatic as it starts it. You just don't want that first instance to start up prior to you changing the configs. So that's running now. Let's go back to the primary installation and see what we've done. Going back to FME server one last time, let's see what the results were. So I'm going to go over to my engine management page again and click on engines. And as we expect, we don't have any dynamic engines yet. But what we do have is a new host, which is the IP that I specified, which is excellent. So I should be able to just spin up some more engines on this. Click change, go OK. And hopefully it won't take too long to then create those. Yep, there we go. We've got the additional engines on 146 now, so we've created yet another node. And let's go to our deployment status and let's just quickly have a look. And we've gone from one box, which is our primary installation with the 6 engines on it, to having an additional 8 engines now spread over 2 different distributed engines and engine installations. And honestly, I could just keep doing this and doing this. The only overhead really is that, aside from if I'm running all of these, I will be starting to chew through credits a little bit, is that I've just got overheads related to the EC2 instances that I'm spinning up. But as far as the horizontal scalability is concerned, this is really easy to set up. And again, I do not have to amend or modify my license to do this. I can just do this willy-nilly. I can spin up as many instances with as many engines as I want. And as far as the license is concerned, I can go my hardest. And with that, I think it's about high time that I wrapped up not only this webinar, but this series. I truly hope that it's been educational and, dare I say, entertaining for people who've been watching. If anyone does want to get in contact with me, as I mentioned at the start of the webinar, please feel free to do so via my email or via LinkedIn. And to everyone who's watched through the entire series, it's been a pleasure.